Okay, so we have been working with large samples, but as you guys know, it's not always practical to collect a large sample. So sometimes our samples are below 30, and when we have a sample below 30, we're going to use the t-distribution instead of the z. Okay, so the first thing that you're going to do is you're going to identify your level of significance. This is your alpha. You're going to find the degrees of freedom, and you do this by subtracting 1 from your sample number. And then you're going to look at the table 5 in Appendix B. This is also on page A18. Okay. So if it is a left-tailed test, you're going to use the column with the, and you're going to add on a negative sign to it. And if it's a right-tailed test, it's going to be the one-tailed column with a positive sign. And when it's two-tailed, make sure you use the two-tailed column, and you're going to have an answer with a negative and a positive sign. Okay, so let's knock out an example really quick. So we're trying to find the critical value T naught for a left-tailed test. Okay, so remember with left-tailed test, we're going to be using the, we're going to be adding on a negative to the value in the chart. So the first thing I need to find is my degrees of freedom. So I'm going to do 21 subtract 1, which is 20. So then I'm going to turn to page A18, and I'm going to find the alpha level of 0.05, and I'm going to go down all the way to 20. And if I do that, I see the number 1.725. But remember, since this is a left-tailed test, we need the negative version. So negative 1.725. Okay. All right, so here we have a right-tailed test. So same thing like I did before, except this time now it's going to have a positive. So my degrees of freedom in this case is 16. 17 subtract 1. So then I'm going to turn to page A18 again, and I'm going to go over to 0.01 on the one-tailed test and then down to 16, and I'm going to see the number 2.583. Okay. All right. Next, let's do a two-tailed test. All right, so this time I'm going to have two values for T naught, okay? So just like before, we're going to find our degrees of freedom. So in this case, it's going to be 26 subtract 1, so it's going to be 25. And this time I'm going to make sure I use the two-tailed test on page A18. And I'm going to go down and I'm going to see that this one is going to be plus or minus 1.708. Okay, so you can use your calculator to find these if you want. And so your calculator steps are as follows. I'm going to type these actually. All right, so the first thing that you're going to do with this is you're going to click second and then bars. Oops, second bars. And then you're going to go down to the one that says inverse T. Looks like that. And then for number 3, your area, what you're going to put in is your alpha. And obviously your degrees of freedom is going to be your degrees of freedom. Now, the only thing that you need to watch out for with this is when you are doing the two-tailed test, you need to divide your alpha by 2. And this is only for when you are typing this into the calculator, okay? So it's really personal preference which one you want to use. I think the chart is pretty straightforward and easy. So you can decide what you want to do with that. Okay, so our t-test for the mean. Okay, so we are going to find the test statistic, the standardized test statistic, and we're going to do that using the sample mean and the standard deviation and Rn. Okay, so just like what we were working with before, we need to make sure that our sample is random and the population has to be normally distributed or our sample size is greater than 30, okay? And we're going to be taking into account degrees of freedom with this as well, okay? So let's run through the procedure. So just like before, we're going to verify that we don't know our population standard deviation. The sample is random and it's either normally distributed or your sample size is greater than 30. Then you're going to state your claim and you're going to identify your null and alternative hypothesis, identify the level of significance, find the degrees of freedom, use the table or your calculator, determine your rejection region, and then find the standardized test statistic. So it's very similar to what we've been working with before. It's just now we are using the T instead of Z, okay? So once you find your test statistic, you're gonna make a decision whether or not to reject or not reject. And then you're going to write your final sentence that is interpreting your decision, okay? So let's go ahead and do a couple of examples. So we have a used car dealer that is saying the mean price of a 2-year-old sedan is at least $20,500. Okay, so his claim is at least, so that means greater than or equal to. All right, the complement of that statement is going to be less than. Okay. All right, so now that we have that, we're going to identify our null and I can never say that word, alternative hypothesis. Maybe it's just because it's before I've had my coffee. Okay, so now that we have that, the next thing that I want to note is this is going to be a left tail test. And how do I know that this is a left tail test? So we've been talking about this before. If your null hypothesis is a greater than or equal to, that's going to be a left tail test. Okay, so left. And this is what tells me that it's a left tail test. Okay. Okay, so let's write down all the other information that I have so I can organize my thoughts. All right, so you suspect this claim is incorrect and find a random sample with 14 similar vehicles, and they have a mean of 19,850. And standard deviation of 1,084. Is there enough evidence to reject the dealer's claim at an alpha level of 0.05? Okay. So my degrees of freedom in this case is going to be 13. Okay, so knowing that this is a left tail test, my degrees of freedom is 13 and I have an alpha level of 0.05. I can use the chart to find my T critical value, which is negative 1.771. So remember, it's negative because it's a left tail test. Okay. So what this essentially is telling me is if I have my curve like this, negative 1.771, Anything over here to the left of that value is in the rejection region. So then we would reject our null hypothesis, okay? So let's go ahead and find the t. So our formula is t equals x bar minus mu over s divided by square root of n. So 19,850 minus, I don't know why that got so high. Okay, if I do that, I'm going to get about negative 2.244. Okay, so then if I notice, that value is somewhere over here, okay? Negative 2.244. Okay, so since it is in the rejection region, guess what? We're going to reject H naught. Okay. So I'm going to write my sentence. Reject H. All right, so my sentence is, there is enough evidence at the 5% level of significance to reject the claim that the mean price of the sedan is at least 20,500. Okay, let's do another one. Okay, so we have an industrial company is claiming that the mean pH level in the water in a nearby river is 6.8. Okay, so let's write that down. So claim so the complement to that is going to be not equal to. Okay, so my H naught is equal to 6.8 and my alternative is not equal to. So since this is an equal, this is going to be a two-tailed test. Okay. So we know that our sample is 19 water samples. So N equals 19. Our sample mean is 6.8. Nope, 6.7. Our standard deviation is 0.24. And alpha is 0.05. Okay, so knowing that I have a sample of 19, that is going to give me my degrees of freedom as 18. And then with my alpha level and my degrees of freedom as 18, and knowing that this is a two-tailed test, I get two critical values at plus or minus 2.101. Okay, so if I were to draw that out, I have two rejection regions. On the right and on the left. Okay. All right, so I'm going to set this problem up just like we did the last one. So we're going to find our t by doing our formula. So we have 6.7 minus 6.8 divided by 0.24 square root of 19. And if I do that, I'm going to get about negative 1.816. Okay, so negative 1.816 is right here. All right, so is that in the rejection region? It's not. So we are not going to reject H naught. Okay, so let's write our summarizing sentence. There is insufficient evidence at the 5% level of significance to reject the claim that the mean pH is 6.8. All right, we're going to do one more. And I'm actually going to show you how to put this one in the calculator. Okay. So the Department of Motor Vehicles office claims the mean wait time is less than 14 minutes. Okay, so our claim is the complement to that statement is going to be greater than or equal to 14 minutes. Okay. So in this case, our H naught is this, and our alternative is our claim. Okay. This is going to be a left tail test again because of this. All right, so we have a random sample of 10 people, and the mean wait time for the sample is 13 minutes. The standard deviation is 3.5. Alpha level is 0.10. And okay, yeah, all right. So our degrees of freedom in this case is going to be 9. Okay. And we're going to actually find our p-value in the calculator and determine if the p-value is greater than alpha, we're going to reject, and if it's not greater than, we're going to fail to reject. Okay. So let me write down the calculator steps, and then let's run through this. So the first thing that you're going to do is you're going to click on stat, and then from there you're going to go over to test. Ooh, I don't know why it's so far down. Test. And then once you click on test, you're going to click on t-test. Okay. And you'll notice you have two options there. You can type in data into a list, or you can use the stats. So when you're using the stats, your mu naught is going to be the claim information. So in this case, it's 14. Your X bar is 13, standard deviation 3.5, your N is 10, and then you need to just make sure you select the appropriate thing that you're solving for. Are you trying to test if it's not equal to, if it's less than, or if it's greater than? And then once you click calculate at the very bottom, it'll give you the t value and your p value, and that's what we care about for this one. We care about p. So in this case, the probability is 0.195. Okay, so then the question is that greater than or less than your alpha? And in this case, this is greater than our alpha level of 0.1. Okay, so since it's greater than, we are going to fail to reject this. Okay, so last thing we're going to do is we're going to write our sentence. there is not enough evidence at the 10% significance level to support the office's claim that the mean wait time is less than 14 minutes.